guys, welcome to part 2, and we're going to be talking about centrifugal force this time. So let's look at our book and let's look at Miss Sloan's one-pager. So in the book, it talks about a tangible acceleration. That's the new thing that we're going to learn. And when we're talking about tangible acceleration, that has to do with the change in speed. Remember, we just got finished doing centrifugal acceleration that was changed in distance. When we were doing centrifugal acceleration, we were using this formula here. Centrifugal acceleration equals tangent speed squared divided by the radius. But now what we're going to do is we're going to do a tangible acceleration. So it gives you an example of a car, and as that car is on the racetrack, it keeps going around in a circle and around in a circle. Well, their tangible acceleration is changing because they have to slow down when they have to go around the curve. Then they speed up on the straight. Okay. So in the book, it's giving you an analogy of a person that is holding a string with a ball on the end. So when you're doing that, when you are doing your vector diagram, you're going to see force gravity, force net equals force centrifugal, and then your force of your string is trying to go that way, and this right here is your force net. It also shows you a diagram with it going in a circle and how it is seeking the center, because that force centrifugal is keeping that ball in motion because of the mass, but the velocity of it wants it to go out, but it's staying it in a circular path because of that holding that in the middle. Okay? So it gives us a formula, and it explains to us when we're talking about this, we're talking about the second law. The second law implies with this, which is force centrifugal equals mass times acceleration centrifugal. So we're going to use this formula for this section. So I want to make sure that you understand. Centrifugal force is centrifugal force equals mass times, okay, velocity at tangible speed. Okay, so that's mass times tangible speed divided by radius. So in the book, it tells us a pilot is flying a small plane at 56.6 meters per second in a circular path. Well, that's our velocity. And the radius is 188.5. The centrifugal force needed to maintain the plane's circular path is 1.89 times 10 to the fourth, and then it's asking us what is the plane's mass. So on this equation, what we're going to do is that this is also a fraction, alpha y enter, right guys? And then we're going to open bracket, 1.89 times 10 caret 4, right? Over, close bracket, open bracket, 188.5, open bracket, close bracket, down, open bracket. And the reason why we're using a bracket, because remember, this is squared. 56.6 squared, enter, and I got 11112090924. In the book, rounded it to 1110. I personally would have rounded up to 111.2, and if you did, then that is fine too. So let's look at the problems that we have on page 230. So on page 230, it says a 2.10 meter rope is attached to a tire and overhanging a tree limb. The girl is swinging on the tangible speed at 2.5 meters per second. If the magnitude of the centrifugal force is 88 newtons, what is the girl's mass? Well, this is the same thing pretty much that we did before, right? Because we're looking for mass again. And so in here, we're going to do this thing here, which is a little bit different. So I'm going to take my force centrifugal, which is open bracket 0.0, close bracket, and then I'm going to do a fraction, alpha y enter, whoops, open bracket 88.0 alpha y enter. It will not let us do that. Wow. So, let's see if we can do it linear. 88.0 times. Let's do open bracket here. And that's 2.10 divided by 2.50. Close bracket, enter. And I get 73.96. Well, let's go back to the problem that we did before, and let's change this to where we're actually finding what we need to find. So let's do it this way. I really don't like it that way. So we're going to do another equation. And the equation that we're going to use is the one that we used before, which is mass equals FCR divided by VT squared. So FC is 88.0 newtons, right? We're going to times that by our radius, which is 2.10. And I'm going to divide that by my velocity radius. And that's going to be 2.50 meters per second. So let's see what I get this time. Alpha y enter. Open bracket. 88.0, close bracket, open bracket, 2.10, close bracket, down, 2.50, and then I need to square that, right? Yes, I do. But that says velocity. Yep, that's right, velocity T. It looked like velocity R. That's Miss Sloan's writing. And enter. I get 73.92. So the answer for that question is still 73.92. So what I did is I did them both two different ways, but I still got the same answer. But you know, sometimes when we do it, we think we know the answer and then we don't. But as I can show you here, I actually proved that and this is the same. So then the next one here is where I'm going to take question number 2. Young boy swings the yo-yo parallel to the ground above his head, and the yo-yo is centripetal acceleration of 250 meters per second. If the yo-yo, oh, I'm on the wrong one. God bless me. A bicyclist is riding on a tangible speed at 13.2. There we go. And around a centripetal track. The magnitude of centripetal force is 377 newtons, and the combined mass of the bike and rider is 86.5 kilograms. So, if I'm doing this one, I'm going to use this formula again because I'm looking for radius. So, I'm going to go ahead and do alpha y enter, open bracket, 86.5, close bracket, open bracket, that is 13.2. Close bracket, down, 377, and I get 3.028647215. So the answer to that question is 3.028647215. But here's the thing. This is in kilograms, this is meters per second, and this is newtons. And so I think, based on that information, what do you think our units are? Number 3 says, a dog is sitting at 1.50 meters from the center of the merry-go-round with a tangible speed of 1.8 meters per second. The dog's mass is 118.5 kilograms. What is the magnitude of the centripetal force of the dog? Well, let's see what we got. I'm going to do my alpha y equals again. Alpha y enter again. And then I'm going to do open 18.5, 1.80, 1.50, and I get 22.2. Okay? So then let's do the last one here. Number 4 says a 905 kilogram car travels in a circular track with a circular motion of 3.25 kilometers. The magnitude of the centrifugal force is 2140. What is the tangible speed? So I'm going to do this. So I'm going to do square root. So I'm going to do second square root. I'm going to do alpha y inner because it's a fraction. Now, open bracket, 3.25 times 10 caret 3 over 2, and then I've got to find the pi key. So that's second here in inner. I get 22.7432091. So, if you look, you will see that I have some different answers than what it says. So, why is that? Why is the answers different? So let's look and see. These questions are practice problems. We just got finished doing page 230. See if I can find it in here.